This conference will now be recorded.
So we will be talking about other things like important logs, how to read logs. We will look at some of the important commands and maybe a simple bash script. I think you are already a developer, you don't need to know, but still we should be familiar with few tools like graphing, how you can grep a string. Sed is for text manipulation. Awk is also that kind of tool, while loop, for loop, if loop, right? These kind of things we should be aware of. So from a, let's say, look at some of the important logs. So let me bring my system up, right? So in Linux by default, what happens is there is a daemon which runs, right? So initially it used to be called syslog. The name changed from syslog to rsyslog, which is now improved version of your logging daemon. So, so it is controlled by a file called rsyslog.conf, right? So this is the config file which controls that daemon, and it tells you various logs where it will go. Let's say all mail logs will go to mail log file, secure messages will go here, right? Info, right? Here I can say my own log as well, where it goes, right? So there's a daemon. If we do ps-ef by grep for syslog, so it will show me there is a daemon which is running, right? So it's a daemon which is rsyslog. So I can do, for example, service. I'm using CentOS 6 command or command prior to 7. So it was rsyslog d restart, which will redirect to systemctl, right? Rsyslog d. Right? So this service I can also play around by using command systemctl restart rsyslog, right? So this is a 7-way Red Hat 7-way of doing things, or CentOS 7-way of doing things, right? So it's a logger which is running. So what this log does, so there is a kernel logger klogd. So whatever logs are generated, they are captured by this log and redirected to respective files, right? As I showed from that config file. So I can create my own config files as well if I am interested. So they will go under this directory, right? I can write under this directory any specific log files with the config extension, and they will be included into it. And I can change the verbose level. Verbose level will be, let's say, info, warn, debug, right? What kind of information I want. So all these logs, they go into var log folder. So here I can see logs. So let's say similarly, your Hadoop logs will go into a particular logging directory. Again, it's configurable where it goes. And you see, let's say a log, right? So I can do a less on messages, for example. It tells me all the messages, or I can tail -f into messages. This is a very good way of looking into what's going on. I'm tailing that message and attach to it in a continuous way with -f option. So whatever entry comes, I can look at that in the real time. By default, if I don't give -f, it gives me only 10 lines. Similarly, I can say head. Head means at the beginning of the line, beginning of the file. So all logs go here. So one important thing for being a good system admin or a Linux admin or whatever is you should be into a habit of reading logs. Go and read the logs. Doesn't matter whether your service is running fine or not. Always read the log to understand what's going on, right? It's not that only when an error comes. So tail hyphen, let's say tail, I do D message. This is the one when your system starts, it registers a lot of devices, all this process. So here you can see like it's doing a clean mount, all those things, right? File system checks, and I can see what went into my boot process. Secure log, mail logs, all this will go here, right? Audit logs, all those kind of things. So I should be aware of where the logs go, how I read them, how I manipulate them, right? I can grab for some strings, I can grab hyphen I, ignore case, let's say error from, let's say messages, right? Right, some string I want to look for, right? Or let's say from D message I want to see, let's say we created a partition called SDA, right? Let's see, do we have any entries for SDA, right? So I can see it's mounting that version file system XFS SDA. Let's see if I check for SDB, right? I'm seeing it's mounting at ext4, right? With ordered data mode, right? So all these options I can check. So I can grep into logs, I can do a lot of operations. So these are simple tools, right? We should be aware of grep, sed, awk at the minimal, bare minimal, to quickly pass through logs and do some very simple scripts. So another important command which I want to show you is, right, PS command. If I execute this PS command, it is process list. It is listing me the processes running in my system. I can do hyphen EF. It is extended list. It is giving me extended list of processes. I can do AUX, right? So I can see what all processes are running, right? Let's say I want to grab for a particular process. I can process that name, right? I can look for it. Echo $PID, right? I can look into the PID of a process and a parent PID of my parent process, right? For example, I'm logged in on a shell. My logged in shell has a parent. His process ID is 3253. I can kill it. I will, obviously my session will go. So each one is that. So I can do an echo $. It will tell me the process ID of my present shell, right? What is the process ID it is running with? So I can do ps-ef grep for 3255, right? So you can see it is a batch shell which is running. You can see that line here, right? Which is a part. I can do 53 as well, and let's see what it is. It is a parent process, my SSH PT terminal. So I can say echo, let's say I should always be aware of what simple outputs or some standard variables shell has, which gives me a peep into the shell. For example, this is process ID. I can look into last command. For example, I do a question mark here. If it is 0, means the last command was successful, right? I can check, okay, actually do something if last command was successful, 0, right? I can do echo colon like that. So simple things I should be aware of. So PS process, it will tell me the processes, all processes running. I can grab for some particular string if I want, right? I should be aware of PS command. Another command I should be aware of is top command. So top command tells me, see if you look here, it is telling me the current time, uptime, how many users are logged in, the load average, right? Which is 5 minutes, 1 minute, 5 minutes, 15 minutes, and it is telling me how many processes are running, total tasks, how many are sleeping, stopped, or in zombie state, right? What is my CPU utilization, right? What is my memory utilization? Which process is using what, right? I can press a question mark. It will tell me all these options. Top, what it will do. I can press letters to switch the sequence, right? So I can say, for example, C, right? So like I can sort it according to different options, right? Different options of utilization. What is using? Let's say sorted in order of CPU utilization, sorted in order of memory utilization, right? I can say show me only for root users, right? Example, show me processes only for root user, right? All those kind of things, right? I can also say top frequency, right? How many times I want to, how frequent I want to run it. Another important command is IO stat. Okay, it's not installed. Okay, let me install. Yum is yum what provides bin slash IO stat. Oh, I am 98 here. Wait. vi slash etc yum dot repos server. The IP has changed to 240. Right. So let's take an example here. I was giving you. Let's say I want to replace the string. IP has changed from 98 to 240. I want to do that. Either I go one by one. Here are only 2 lines. It will not take me time. But let's say there are 1,000 entries in the file where I need to replace it. One is I copy paste in a text and do a replacement by searching. Right. I can do it here. Right. I press colon. I go into command mode. I say percentile s, which is a string. I say replace 98 with 240 and replace it across the file. Right? So I can do this. So let me go and start my, I think my server, repo server is not running. Right. So now I'm seeing what provides iostat command. Right. So it is telling me sysstat package provides me that command. So I will say yum install sysstat -y. So what iostat command tells is, it tells us the statistics about IO statistics, right? So if I do iostat default, see I have disk drives. If you remember from yesterday's class, we added 2 disks, and this was when we installed our operating system, disk 1, disk 2, disk 3. So it is telling me TPS, transactions per second, kilobytes read, kilobyte writes, and all. I can give -m here. It will tell me in megabytes to make it more readable. So I can look at the disk performance, what it is, how much time particular operation is taking. Also, it is taking me the average CPU time as well, right? So here you can look at how much is the read write and all, right? Which is a good way of looking into how my system is performing. I can look for a particular disk by saying -p, let's say SDA, right? So I can look into that particular disk. I can ask for extended attributes as well, right? Instead of this, I can say, give me extended attributes. So extended attributes means it will tell me the average queue size, request queue size as well. Read request, write wait. How much is the wait time for read and write request, right? So this will give me a good context into what how my disk performs, right? For example, again, this is very detailed thing. For example, let's say average, this is average queue length of requests that were issued to the device, right? Our system is not very busy. Await is the average time in milliseconds for the IO operation we are doing for it to be served, right? 15 milliseconds it took, right? Similarly for read, similarly for write, right? This field is also very important, svctm, right? But what happens is this in the recent versions have been deprecated, but still we are seeing that in the old version this was quite a significant value. This is utilization percentage of elapsed time during IO requests were issued to the disk, right? So all these things, it's very important to see that. So if we are seeing a lot of await time and all, we know that there's some issue with the disk. So when we say some issue with the disk, it's not necessarily always bad blocks or all, right? Mostly like nowadays the disks are good, right? But especially let's say if I'm on a cloud environment where my virtual disk will be shared, right, in with other tenants, then I will be seeing a lot of disk issues, right? What kind of disk I have, what is the IO throughput of the disk I have, right? How many IOPS I have for that disk will be very important, right? Especially for Hadoop, Zookeeper, Journal Node, they are very sensitive to timeouts. So if I give them slow disk, I will run into a lot of name node availability issues, a lot of false triggers, failovers, Zookeeper timing out, right? All those kind of issues. So it's good to always test the disk performance, right? So again, there are a lot of details to look for into. For example, one of the very important factor which is important is, in addition to looking at the disk queue depth and all, which is controlled by sysctl parameter, there are also schedulers, which we call them the disk schedulers. So what does disk scheduler mean? If I do, let's say cat I think sys in the block, I will have sda, yeah, sda I have, then I will have a queue and I will have a scheduler here, right? If I hit and enter on that, you can see by default the scheduler is deadline, right? So deadline scheduler name has come. It is based on a timeout, right? Deadline means there's a timeout. For example, for read operations by default it is I think 500 milliseconds, and for write it is 5000 milliseconds. So read, if my workload is read heavy, I will go for deadline. If I'm using like this is a fair queue, CFQ is a fair queue queuing scheduler, like complete fairness queuing scheduler. If I'm looking for each processor should get a fair kind of a disk access, I'll be using that. NOP is a FIFO, right? So depending on my workload, I will change it, right? This is not that very significant. Let's say it might make a performance difference of maybe 2-3%. But first thing always will be to look for, let's say, let me take an example from our Hadoop world, right? Because I'm targeting these sessions of Linux towards that. I say my Hive query is slow, right? So, okay, we can look into some direct hints, right? I can quickly go and check into system. Okay, is my some disk slow and all? But obviously, if my disk a Hive query is not written in a right way, it's not optimal, then all these things will not be of that importance, right? So my first thing will be to optimize that Hive query. Second will be then look at stage by stage. Okay, now let's look at whether, okay, it does it, my system has sufficient memory, how is my disk? Then you look at do I see any kind of a disk bottleneck? Okay, do I see any disk depth queue issues? Do I see any scheduler issues, right? So we will go one by one, right? So we should be aware of the scheduling queues and all that as well. So again, this is a very detailed topic, like a knob, which one we will use. I can set this by echoing it into this, or I can set into a grub while booting, all these options. So this plays a important role, right? So another important command which we should be aware of is lsof, list of open files. Okay, again, this is not installed, which what provides lsof. Okay, lsof itself provides that. Yum install lsof. So lsof is a very important command. It tells me list of open files, right? Let's say you are running out of file descriptors. Example, you can see how many files are open. I can also specifically go and look for which PID has a file open, right? Let's say on the left hand side, there are too many lines. Let me just reduce the lines. I say ls open pipe. Let's say I say head. Let's look at 10 lines. So it is telling me system D is the command, process ID is 1, this is the user, this is the file descriptor, this is the type, this is the device ID, major minor ID, size, node number, and the file, right? I can look into that. I can, let's say I'm running some PID. Let's say I'm running a name node. I can grab for that name node's PID and see which libraries are open, which files is open for that process. Right? So CWD here is current working directory. Right? RTD will be root directory. TXT is your program text code. Right? Mem will be your memory mapped file. Right? So all these are different file descriptors. So here, right? So I can do multiple things. So here this is directory, regular file. All are regular file, right? I may have a FIFO, I may have a maybe a character device. So let's say I want to look for all open files for user. Let's say Pawan. I'm not sure we created Pawan user here or not, or Pawan is not there. Root. Let's say root. So it will tell me all files open for root. Okay, root has a lot of open files. Let me just quickly create a small user. User add GST, right? And I will give GST. Let's see, are there any open files for GST? None, right? So this way I can check what files are open. I can also look for, let's say I have a port. Example, name node is running on a port, let's say 9000 port. I want to see what all files, or let's say what all running processes are on port 9000, right? So I don't have name node, but let's take an example, 22 SSH is running. So I want to see for port 22, I can do -i. I want only TCP. I can say colon 22, right? So it will tell me IPv4 SSHD twice. This I'm connected from to that server from my 81 is my desktop IP, right? I'm connected from this. This is my open connection, right? So these are the processes which are running here. This is my PID. So I can list, let's say I want to list only the open files for IPv version 4. We don't have IPv version 6 running. I think 6 is bare minimum. 4, I can list that. I can list, let's say, a port range. I can say -i, let's say TCP protocol. I want only TCP1. Let's say from port 1 to, let's say, port 22. I want this range. Tell list me all. Let's increase the range 1024. Let's say, right? List me all the all running processes of open files for this particular TCP port. I can also negate. Initially I was saying user hyphen I root. I can also say hyphen user, let's say root, right? Give me processes for user root, or I can negate for user root. I say I don't want root user, right? So like this. Anyway, I don't have any other user, so it's showing empty, but I can go there. I can also search by PID, list of ls-p, some process ID. Let's say 1 I give, it will tell me that process what it is running, right? So let me just take this process ID, for example, right? So I can see, let's say name node process, I can see what all list of files are open by a name node. I will take name node's process ID and give it. Very powerful command, right? I can also kill by using passing this from that command, right? So these are very important commands you should remember, right? So let me see. Yeah, I've talked about these. Uptime, IOStat I have talked. Uptime, let's say uptime. And what is uptime? Uptime is the time which is it's telling me when the system is up since what time. One user load average, right? So load average is also very important to understand. Again, this is quite detailed. Let's say your load average says 1. It does not necessarily mean that it means 100% utilized. It will depend upon the number of cores you have. Let's say if I have a single core CPU core system, right? When I saying a single core CPU, I means it's not hyper threaded. Only there is one single thread, and I see 1 here. It means it's 100% utilized. If I say 2, it means 200% utilized. But if I have 2 cores here and I see 2 value here, it means each one of them is 100% utilized. If I have 4 cores and I see 2 here, it means 50% utilized. So it's very important that we don't just look at this value and say, oh, I need to bump up my CPUs, increase my CPU cores because I'm seeing high utilization. No, this is correlates to the number of cores I have. So it's very important we understand this. Another command is free. If I do free-m, it is telling me total memory available, used, free, shared, and buffered, right? I can buffered, I can always drop this much memory is available, right? I can say swap, right? I can say swap on -s, right? It will tell me what is this swap size I'm using, right? Here, right? A lot of things we can check. For example, in terms of I can do VM stat, right? It is telling me what is the swap statistics. I can give -x 1 2 wait stat. Oh, okay, there's no x here. So actually I can give here two periods of 1 second difference each, right? So I can look into how much swap is performing. Let's say if I give 8 number here, so this will run 8 times at an interval of 1 second, and I can check how is my system performing in terms of memory, right? Page in, page out, right? Block in, block out, right? And then how many times it has swapped free. My system is not loaded, right? So we don't see much. So these are all good tools to identify what's going on with my system, right? So this we have looked into. So Astrace is one more thing. Astrace helps us in finding out what's going on with the process. Many times in Hadoop world, we see a particular process hung or taking too much time, let's say a name node process or a zookeeper process. So what I can do is I can trace that. I can say yum install asterisk, and I can run that asterisk on a process. I can say asterisk -p a process ID, right? So that process gets attached to it, and whatever it does, it shows up here, right? The whatever it's doing in the backend, I can detach. It's very important, handy tool to have. Another important tool is tools of JVM, right? It's very important that you understand JVM, right? How GC cycles work, what is young generation, what is old generation, how it collects, right? You should understand tools like JMap, right? JStat, right? All these tools you should understand. They will be part of your JDK. In my case, presently JDK is not installed, but you should be knowing that JStat, JMap, right? How it works. Okay, so I think this is pretty good overview to quickly run through. If you have any question, it's fine, let me know. Else we will just close this session.